This video will help you to solve the questions on homework number 12. So let's take a look at that first section here. State if the equation shown is linear or nonlinear. Remember, to be linear means that you can be written in y equals mx plus b form. That's it. That is the rule. You can be written in y equals mx plus b form. So that means no powers for you, no square root signs, no absolute value bars, none of that. No variables in the denominator, and no products of variables. Right? So those are the three rule breakers that we're looking for. No powers, no variables in the denominator, and no products of variables. So question number 1. No powers, no products, and no variables in the denominator. So that's linear. No powers, no variables in the denominator, no products, so that is also linear. Number 2, well, that has a power. So that breaks the rule, and it's nonlinear. Number 2, no powers, but it has a variable in the denominator. So that is nonlinear. Number 3, any powers? No. Any variables in the denominator? Any products of variables? Well, this one's good. That's linear. Last one, any powers? No, but it also breaks this other rule, right? No square root signs, no absolute value bars, so that one is non-linear. The next question asks you to explain in words how you were able to determine your answer for this equation. Well, I'm going to give you a response that works for every single question. It doesn't matter. Whether it's linear or nonlinear, this is the statement you go to. This equation, and now this is the only thing that's going to be different. You're either going to say can or you're going to say cannot. This equation cannot be written in y equals mx plus b form. That's it. That answer works for every question. It works for this one. It works for this one. It works for this one. They can all be supported with that one statement. The fact that you cannot be written in y equals mx plus b form means you're nonlinear. Now, if I asked you to explain in words how you know this one is linear, you simply take that word out. This equation can be written in y equals mx plus b form, therefore it is linear. Next section. Find the rate of change for the following data. Well, your brain should be thinking change in y over the change in x. So set up that ratio and label the parts if you need to, right? Point number 1, point number 2. So y minus y over x minus x. And anytime you have two minuses in a row here, you make a giant plus sign. So it looks like we're going to get negative 2 over 0. But if you have a 0 in your fraction, you must go one step further. You must interpret it because there are two places a 0 can be, the numerator or the denominator. A 0 in the numerator, that's 0. But a 0 in the denominator, that's undefined. So you must interpret that and go one step further. You cannot just leave it as a fraction. You can't just circle this fraction and think you're done. You can't do that because you have to interpret it. All right, question 6. Identify the rate of change in the following linear equation. Well, the rate of change is your coefficient of x. Not the letter x, just the coefficient. Question 7. Which of the following graphs represents this equation? Well, let's use our common sense. The rate of change is positive 1/3, so that means I need an uphill line, right? It's positive 1/3. The y-intercept is negative 3, so that means I need to cross the y-axis at negative 3. All right, first check. I need an uphill line, or uphill data points. This, not uphill. This one, yep, that's uphill. This one, not uphill. This one, that's uphill. So I'm down to 50-50. Let's use our second rule. Y-intercept of negative 3. Well, if you have a y-intercept of -3, you cross the y-axis at -3. And this is the only one that does. Simple stuff. Use your common sense when you're looking at the equation. Let it guide you to making a right decision. Let's turn the paper over and try this word problem on the back. 3 faucets, A, B, and C, are filling tanks of water. The graph shows the relationship between time and volume of water for faucet A. The equation shows for the volume of water for faucet B and the table for faucet C. So let's look at our first question. What is the slope of the graph shown? Well, it looks like from data point to data point, I go up 1 unit and over 2, up 1 and over 2, up 1 and over 2. But I want you to be very careful because that is not the answer. I do move up 1 unit, but look at the units on your y-axis. Do they go by ones? No. It looks like the units on my y-axis go up. Each box is 5 gallons. So instead of saying up 1 over 2, I'm going to say up 5 gallons over 2 minutes. Up 5 gallons over 2 minutes, right? So the slope is 5 over 2. Now I'm not sure if you heard what I was just saying, but when I ask you what does this slope represent, I'm asking you to tell me what does it mean in the context of this problem? Like, what are we even talking about? We're talking about a faucet, filling a tank of water, and we're talking about its rate of change, so that means how fast it's filling. So I want you to look at your axis labels to help you with your description here, to help you with your description of what the slope represents. So I know the slope is 5 over 2, but what does 5 on the y-axis represent? Well, 5 represents your gallons. And what does the 2 on the x-axis represent? Well, the 2 represents your minutes. So what does the slope represent? It represents 5 gallons every 2 minutes. Now, most people, when talking about rate of change, they like to have a unit rate, right? So they like to reduce this down so that the denominator is a 1. So if I asked you for the unit rate here, you would have to divide or reduce this fraction to say that 5 gallons every 2 minutes means 5 divided by 2, or 2.5, 2.5 gallons per 1 minute. So that's what that means. What does the slope represent? The speed of the water. That's what it represents, right? How much water is coming out every minute. Question number 10. The relationship between time and volume for faucet B is given by the equation. Find the rate of change for faucet B. Well, that's simple. Look at the coefficient. So the rate of change is 5. But don't forget this last one was a fraction, right? 5 gallons every 2 minutes. So let's represent this one the same way. 5 gallons every, there's no number here? Do you remember what to put? That's right, an invisible 1. Find the rate of change for faucet B. It's 5 gallons every 1 minute. 5 gallons per minute. All right, how about faucet C? Faucet C is shown in a table. So when you find the rate of change in a table, you find the pattern of the y value and you put that over the pattern of the x value. So it looks like I have 8 over 2. Now what about this one? It looks like 4 over 1. And what about this third one? Wow, these are all different. It looks like 12 over 3. So is that faucet changing speed? Well, 8 divided by 2 is 4. 4 divided by 1 is 4, and 12 divided by 3 is 4, so I think these all represent the same thing. 4 gallons every 1 minute. So that is the rate of change for faucet C. Now let's recap. This first one was 5 gallons every 2 minutes, the second one was 5 gallons every 1 minute, and third one, faucet C, was 4 gallons every 1 minute. Right, so let's put those labels in. Gallons per minute, gallons per minute, gallons per minute. So these both have unit rates. So let's turn this one back into a unit rate. Remember, it was 2.5 gallons per 1 minute. And now I can compare to find out who has the greatest rate of flow, because they're all unit rates now. So 2.5, 5, or 4? Well, first let's answer the question. Faucet B has the greatest rate of flow. How do you know? Faucet B has the highest rate of flow. Whoops. At 5 gallons per minute, which is higher than 2.5 gallons per minute and 4 gallons per minute. Right? All right, I hope this helped you to answer the questions on homework number 12. Now give yours a try.